good place to learn. This is, again, I showed you this last week, but this is called Khan Academy, and that guy's name is Salman Khan. And so that was the first of the Algebra 2 videos. And then he goes on to just talk about more. Okay? All right? And this is very good if you feel that you're weak in any particular area. You can go back up. I think that you have to go back several levels back. Like if you're weak in this, you shouldn't start right here. You should probably start at the beginning of this and go through it all, something like that. But anyway, so this is called Khan Academy. I told you about it last week. And anytime you feel that you're having trouble, I think going here can be a good step to take to try and solve that. Okay, now let me first of all go through read out some people's names. These people registered for, I believe they registered for WebAssign already, but they didn't seem to do the homework. So I'm not calling this out to embarrass you. I just want to mention it. So there's Karin, Jian, Joshua, Kwan, Lynn, Sarah, Shanila, Shireen. I think I said that already. No. Ut Nasan, Yiwei, Rasulov. Well, Rasulov actually did some, but okay. So anyway, I have a list here of people that. Well, anyway, okay. So that's that. So you need to do the work, right? And you don't want to accumulate 0 points for a homework assignment in general. So this first week I can understand that you had some trouble or something like that, but for the future you need to do homework. Okay? And now I want to tell you that we have 2 assignments due next week, and these are not, unfortunately, not small assignments. They're each 25 problems, I think. So there's 2 of them. Wait, I need to go there, to go to you. So, 25 in the first one, and about 25 in the second one. So you have a lot of problems to do, but they aren't very hard. So you should get started on them. And the due date is Sunday at 5:55 p.m. And that's generally the due date for all of our homework assignments, is Sunday, 5:55 p.m. Okay, remember I told you that you can set up notifications. So I do suggest that you do that. So whenever I post homework, you'll see, hopefully you'll get an email. Okay? Okay, now, let's, now sometimes I thought, I'll teach the class by lecturing or talking up at the board, but I'm not sure if that's the most exciting way for you to, so anyway, I thought this time we'll try and go through some of these problems. So that might be a way to conduct our class. Now after a few more minutes, I'm going to ask a certain set of people to step outside and discuss with our TAs about a second meeting time for the class. So it's going to be a help session. It's completely optional, but if you want to get some help on problems from our TAs, we're going to have it one maybe 2 times a week when you can meet, and the TAs are gonna meet with some people in a few minutes and try and decide what day that is. And then after they decide, they'll come back here and we'll try and put it in front of everybody and try and find a good time to meet. Okay? But we won't do that for a few more minutes. All right, so let's take a look at some of these problems. That's one way to learn. So here it says, can you read this? Is it big enough? How about that? Evaluate or estimate each expression based on the following table. Okay, so here we have, so maybe I might ask some people to come up and write these on the board. Oh wait, I didn't want to do it this way because it has the answers. Go to that. Who's talking? So here, evaluate or estimate each expression based on the following table. And so let's just watch this for a second, just see if there's any, how interesting it is. Good.
Evaluate or estimate each expression based on the following table. We're given a table of values for x and a table of values for the function of x. And here we're given the function of -1. So going along this table and finding in the x row -1, we then go down to the f of x row, function of x, and find that that corresponds to 4. So the function of -1 in this case is equal to 4.
Okay, that was pretty easy, right? So, sometimes we're given a function that looks like this. We're given the definition of a function like that, and then we might be asked the same kind of question. What about when x is -1? What's the value of the function? So that question might be written like that, and the answer would be what? Would be 1, right? Because -1 squared is 1, right? So sometimes we're given a definition of a function like this, but they're also saying we could be given a function definition by a table. Okay, so it's the same. I mean, the result might be similar, but the way that we explain the function to another person is, instead of giving a formula like this, we say, no, take a look at this table, and then tell us how the function works. Okay, so that's what they're doing here, instead of the formula. Okay, so how about the second one? How do we do this one? So it says, in part A, it says f of 2 minus f of -2. So f of 2 is what? That value. And f of -2 is what? This value. So what are we asking? We're asking 0.5 minus 3, right? So what is that? That's minus 2.5, right? Okay, and this one we're doing f of -1. What is that? 5. And f of -2, what is that? I'm sorry, -2 is 3. And we're multiplying those two numbers. So we would have 3 times 5, so we put 15 in here. Okay, so everyone get the idea? It's not very hard. Same kind of thing here. Okay, same kind of thing here. Okay, now how about this one? Use the graph of the function those two girls. horrible noise. So, okay, so here, use the graph of the function f to find approximations of the given values. Okay, so now we're not given the definition of the function this way, and we're not given the definition of the function this way. So here we're trying to tell somebody about the function with a picture of the function. Okay, which is another way to try and tell someone the function. So here's the picture of the function. Okay, and so what is f of 1? Now, it doesn't give us a table to tell, so we don't have a table to know the answer, and it doesn't give us this formula to know the answer. So do you know how to get the answer from the picture? So what does it mean? So what does this graph mean? It means this is a picture of the function, and when x is equal to 1, it means that the height is, it means that the value of the function, that is what it's equal to, is given by the height of that curve. So what is the height of that curve when x equals 1? So it's 2a, right? Okay? So you could say the answer is 2a, but they don't quite want you to say 2a. I mean, 2a would be okay, actually, it would be fine. But they want you to say what? They're saying, suppose a is 45, so what is 2a? 90. So they want you to say 90. But I would accept 2a. But in this system, they won't accept 2a. They want you to say 90. So how about f of 2? So again, this picture is trying to tell us the definition or the rule that, for this function. So when x is equal to 2, the value means what's the height here. So what is the height here? 3a, which is what? 135, right? So you would type in 135 here. Okay, and the same kind of thing here at 3. It looks like it's the same answer, right? I think. So it would probably be 135 again. Okay, everyone get that? Okay, how about this one? Looks a little bit more complicated, but the idea is exactly the same. The only sort of messy part of this one is like here, at -1, you'd say, what's the height here? At -2, you'd say, what's the height here? At 0, you'd say, what's the height here? The only kind of tricky part to this one is, how about at this value? We'll say this is +1. Actually, it's a, but suppose it's +1. So at +1, what is the height? So let's suppose this was 2. So is the height 2 or something else? So you have to understand the notation that they're using for this graph. Because you might think, oh, it's 2. Or you might think, oh, no, it's 0. So we have to decide, right? We have to have one answer. And they just use, the notation they use is, if you have an open circle there, don't use that value. We're not using that value. If you have a closed circle, that's the value we're talking about. Okay, it's just a notational rule, right? We need some kind of rule to visually express it, so that's what we do. We use a circle, open circle versus a filled-in circle. So what is the value when x equals a? What's the height of the function here? Is it this height or is it this height? It's 0, right? Okay, do you understand? It's just a notational thing here, right? Okay, does everyone get that? Any questions? So the answer at a, by the way, a is what? 4. So the answer at 4, when x is equal to 4, the function, or y, either you can say the function or you can say y, whatever, whoever, some people will say y, some people will say the function. You can say it either way, but you have to be able to handle what someone else says as well. If they say y or x, I'm saying y or the function, you have to know what they mean. So, okay, so the function is, when x is equal to a, or when x is equal to 4, the height of the function is what? Is what? No, we just said it's not 8. It's what? It's 0, right? This filled-in circle is the number, is the value. The open circle, no, it's not that. Now you might say, well, what is going on here? Why do they need to do all this? I mean, why do we need this open circle, this filled-in circle, and all that? It looks like such a pain in the neck, right? Yeah, it does look like a pain in the neck. But there could be some kind of function that, some kind of behavior that follows this kind of pattern. In other words, it might be like, maybe this is, let's see, x might be the number of, well, I need something that could be negative. What could be negative? What? What? I can't hear you. What's gaps?
Debt.
I don't know what that is.
Loan.
Oh, loans. Okay, right. So this might be the amount of money that you have. And if it's negative, let's say you have a debt. Okay, that's a good idea. So this is a debt, right? So, so x might be the amount of money you have. So if it's negative, it means you have a debt. If it's positive, you have none. And this might be, the y value might be, what? Okay, for that.
Budget.
What?
Budget.
It's too complicated. Something else. Something else. Simpler. Okay, this is a really stupid example. It doesn't make any sense. But the number of friends that you have. Okay? So that's a really stupid example. But let's say it's the number of friends that you have. So if your money is, if you're completely break even, if you don't have any money, you don't have negative money, you don't have positive money, you have this many friends. Okay? And as your debt increases, your number of friends gets lower. But, this is completely nonsense, but as your debt as the amount of money increases, what happens? You get more and more friends, up to a certain point. It doesn't, I told you it doesn't make sense. When you reach this amount of money, then your friends go all the way down to 0 for some reason. I said it doesn't make sense. And then, what happens? But then as you go up, some reason it goes up, and then it drops down. Okay, like I said, it doesn't make any sense. But, you know, you might be able to come up with some real world situation that does behave something like this picture. Okay? That's all I'm trying to say. Okay? Alright, so that's that one. And then you can do the same. Okay, so what is f of negative 12? So negative 12, if this is 4, so this is negative 4, negative. So here, negative 12 is here, right? So what is the value there? Negative 4, right? So you put in negative 4 here. And here you do 0, and blah, blah, blah. Now 0, that looks awful. I didn't want you to have to do this kind of problem, because you have to guess at what the height is here. What? Yeah, I would say 5, but I'm not sure. I didn't mean to have that kind of problem, but let's see what happens. Okay, now this is the same kind of situation, so we don't need to go through this one. Say whether or not f is defined for the given values of x. Okay, so what does that mean? That means, like here, this is the function, and the domain, what does domain mean for a function? What? Yeah. That's the set of inputs that we're allowing you to even consider for this function. So when I say this is the domain, I mean you can't even consider as an input 1 or 1.5 or 1.8 or -5 or anything like that. Anything less than 2, don't even consider it. That's what we mean by the domain. It's just the set of possible inputs. So what are the set of possible inputs? Anything from 2 to anything larger than 2, including 2, right? This thing means include 2, right? Okay, so if you understand that, then, so is F defined at 3? Yeah, it is 3 so first thing is, you say, is 3 a possible input for F? And what's the answer to that? Yeah, we said anything greater than 2, right here. Okay, so it is defined at there. So then you can figure out what is F of 3. So how do you do that? It's 2 over 3 minus 9. Okay, so you can figure that out. And this one, how about at 0? Is it defined?
Undefined.
It's not defined, so you put undefined in here. Okay? Like that. And how about F of 1? Is it defined at 1?
Undefined.
No, it's not defined. We say it's not in the 1 is not in the domain of F. Okay, that means you can't even put 1 into F. Okay? Okay, how about this one? What's the given domain? There. Okay? Now, is 0 in the domain?
Yep.
Yes. And by the way, what do the round brackets mean here? By the way, this does not mean the point -7, 7. It doesn't, it's not referring to a point. I said, this notation is ambiguous. Right? But here it doesn't mean a point. It means a domain. They give you a hint by saying it's domain. So it's a domain, which means it's a range, it's an interval, or a set of intervals. So it goes from -7 to 7. So is 0 in the domain? Yes. So then you can figure out what the answer is. By the way, what is the answer here? So you put in 0, what do you get there? Oh, no, what do you get here? 0. 49 minus a 0 is 49. Now here's the tricky part. What's the square root of 49? 7. It's not -7. Now, in high school, we're taught to say, yes, -7 and 7. But in this course, in calculus-based courses, whenever we have the square root sign, we mean only a single answer, not 2 answers. And we mean the positive one. So it's not -7. It's just 7, okay? So you have to change your definition of the square root for this class. Okay? So it's not both of them, it's only 7. Okay, and then you can go on to the rest of these. Okay, these are all similar. How about if f of x is equal to 4x minus 6, this is easy, -1, you just put it -1 there. How about f of a plus b? So what do? You replace, okay, how do we do this one? We replace x by what? By -1. How do we do this one? We replace x by 0. How do we do this one? Replace x by 1. How do we do this one? Replace x by y. How do we do this one? Replace x by a plus b, and whatever you get from that is the answer. So you could say it's 4a plus b minus 6. I hope they accept that. Same idea here. Here it's not a plus b, but rather x plus h. So you put in x plus h here and here. Is that clear? Okay, is Brian Sims here? Brian Sims? Here or not here? Brian Sims is not here. Okay, so that's absent. You can make sure we mark him absent. And is Misra Priya here? Okay, so Misra, can you come and do this on the board? Here, this one here. Don't be shy. I have to sit up here. You can learn how to do it too. I was super shy. I learned how to do it. On the board. Okay, wait, who's the person? Oh, no, it's too late. Who's the person that just gave you the answer? What's your name? Okay, you can do it. For her. You don't even have to talk. You can just write the answer. Yeah. Okay, so it's, yeah, that's that one. X squared plus 5x plus 8. X squared plus 5x plus 8. And then they say f of x plus h. Right. Right. Okay, that's okay. That's good enough. And I don't know if this system will accept that answer, but that's basically the answer. I mean, then you could expand it. Maybe they want you to expand it. Okay? But that's basically the idea, right? I'm not kidding. Okay, thank you. Very good. Mr. will do it next time. Okay? Anybody have any questions about that? Okay. Same thing here. They just do x plus h again. Put it in here. Anybody have any questions about how to do this? Okay. Okay, how about this one? Graph the given function. We suggest that you become familiar with this graph in addition to those in table 1. Okay, so here's the function. The function is minus x cubed. Now, first of all, is that the same as this? Minus x cubed and minus x cubed. Well, maybe it is the same, but formally it's different. Turns out to be the same, but formally it's a different thing. The order of these is actually different. This one, first you do the cube and then take the negative of it. This one, you take the negative of it and then cube it. It turns out that they happen to be the same, but that's a kind of coincidence almost. Okay? So you need to be careful of those kinds of things. So anyway, we have this function, and the domain is what? Everything, right? No restrictions on the domain. Okay? That's what that means. Okay, now, what are they asking us to do, though? They're asking us to graph it. Now, they don't actually ask us to graph it, they just ask us to choose the right graph. Okay? So, what is it? So let's see, what are our choices? This one, that one, which is similar to this one, and this one, which is similar to that one. So first of all, let's decide, is it this type or this type? And then we'll decide, is it this type or that type, or this type or that type? So is it this type or that type? Or is it some other type? Well, let's just think of this, because that's the one I know. So what's that look like? Well, to compare, what does that look like? That's, everybody knows that, right? Everybody's completely familiar with that. That's the parabola, right? So what's the difference between this one and that one? Well, first of all, it's a higher power. It means it grows more quickly, right? So if x is equal to 2 here, you get 4. But if x is equal to 2 here, you get a bigger number, right? You get 8. So it grows more quickly, right? But besides that, what's the difference? This one, when you put in a negative number, the result is positive, right? But what about this one when you put in a negative number? The result is negative. So so this one comes back up on this side, right? Because it's negative. Negative numbers still give you positive. But this one doesn't do that. So therefore, on the right side, it looks basically like this, but we said it grows more quickly, so it looks like that. But on the left side, it doesn't come back up, so it looks like that. So is it the, I'm sorry, so that's that one. Now, what about this? So now, whenever it was positive before, that's this, by the way. Okay, so now whenever it was positive before, it's what? Negative. Now when I say it, I'm talking about the function, but when you're talking about the picture of it, when I say it is positive or it is negative, what am I talking about in terms of the picture? The height. When I say the function, we mean the height of the function. Because that's the output of the function, right? The output of the function is represented by the height. So when I say it's positive, I mean the height is positive. When I say it's negative, I mean, in terms of the picture, I mean the height of the function is negative. Right? Okay? So, where this one had this shape, and now what are we doing? We're making it negative. It means what? We're reversing the heights of the function. Right? So what does that mean? That means before, when it was positive, the height was positive, now it has to be negative. Right? And before, when it was negative, it has to be positive. So minus does that to it, right? Okay, now we just have, so we've narrowed it down to what? This one, this one, and this one, right? Now we just have to figure out which one is better. What's the difference between these two? At -1, this one is 1, and at -1, this one is less than 1, right? Yeah, okay? So which is appropriate? At -1, what is this? It's -1, sorry, it's 1. Because -1 times -1 times -1 is -1, and then negative of that is +1. Right? So at -1, this is +1. So that tells us which is the right one, right? Because here at -1, this is not +1, right? The height is not +1, right? Remember, I don't know how many people get confused by when I say it's not the height, I say it's not -1 or it's not 1 or whatever. When I say it, what am I talking about in terms of the function, in terms of the picture? The height, right? So, how about here though? At -1, it is what? 1. So this is the right answer. So the answer is here. Okay? So the answer would be that one, so you click on that one. Okay, now, next thing they say is give the technology formula and use technology to check your graph. Ugh. Anyway, they just want you to choose this kind of notation. They want us to learn this kind of notation. So when we write -x cubed, how can we write that using, basically by the way, what they mean by technology is, can you write it in a flat line? See, when you do x cubed, if you try and type that in Microsoft Word or something like that, you have to fool around with subscripts and superscripts and all that, you know what? Maybe you don't do that very often, but if you have to type a math quiz, if I have to give you a math quiz and I have to type it out, I have to fool around with, keep writing superscript squared and superscript cubed and something. You keep having to shift back and forth. It's troublesome. So what this technology notation is it allows you to do it all in one flat thing. Okay? So how do you do it? What does this mean? This is read caret, by the way. Caret. This symbol is read as caret. I don't know why it's called caret, but that's what it's read as, caret. So, so caret means what? To the power of. So if I write x caret 3, means x cubed. Okay, but I don't have to use subscripts and superscripts, right? So that's why they do that. Okay? So what's the right one? Yeah, the last one. This one is okay, but I think this is the right answer. This turns out, remember I said, this turns out to be the same thing, but it's not exactly, it's formally different, literally different, even though it turns out mathematically to give the same answer. But literally it's different. Okay, so you choose this answer. Okay, any questions about that? Okay, graph the given function. We suggest you become, okay, so here's another one. X cubed. So you say x cubed, we just did that. I just did x cubed, it looks like this. So why do they have a different kind of picture there? Right, you get confused. Why do they have a different picture there? Doesn't look like what I drew. I feel annoyed. I feel troubled. I feel like this is troublesome, pain in the neck. Why? Why is it? What's going on? The domain is limited. The domain was infinite before. I mean, it's still infinite, but the domain was everything before. Now it's where? It's only from 0 to everything greater than 0. Okay? Okay, so that's the difference. So it's not, the picture is not going to be the same. So obviously this is wrong. Right? Because this has negative values, that's obviously wrong. And obviously this is wrong. Right? Because it's not even defined over here. Okay, so we have to choose between this one and this one. So what's the answer? We already did this, so it must be this one. Okay, how about this one? Graph the given function we suggested we come to. This one. The cube root of x. Where is the domain here? The domain is everything, right? Okay. The cube root of x. What about that? What does that look like? So how about the cube root of 8? What does it mean, the cube root? It means what number do I multiply times itself 3 times to get 8? So what is the answer? 2 times 2 times 2 is 8. So what's the cube root of 8? 2. Now, what's negative 2 times negative 2 times negative 2? Negative 8, right? So what's the cube root of negative 8? Negative 2, right? Negative 2, right? Okay, so that should kind of help us to see this. So the cube root of negative 8 is negative 2. So could this be the answer? No, because this one, there is a cube root of negative 8, but this one says there's nothing, right? It says the cube root of negative 2, there's nothing there. There's no answer. That can't be right. Okay? How about this one? Could this be right? Yeah, it could be right. But it says that there are going to be 2 cube roots for negative numbers. And also, it's not right over here. Because the cube root of 8, if we go all the way over to 8, is what? We already said it's 2, but here it says there's nothing there. So this is not right either, for 2 reasons, at least 2 reasons. One is because there's nothing over here, and the other is it says there are 2 cube roots, but there's not 2 cube roots. Okay, so we're left with what? This one or that one? Or which is it? Which one? The bottom right one, right? Right? Because this would say that the cube root of 8, here's 8 over here somewhere, is what? Is negative, but that's not true. Right? Cube root of 8 is positive. Right? So this is wrong. So this is right. And then what's the right technology formula? So this is the way they write cube root here. Okay? That's kind of a pain in the neck. Okay, and more, and more, and more. Okay, let's how about this one? So we're doing your homework, so that should make you happy. because of course you have to do it yourself, but we're doing it. Match the functions to the graphs when A equals 4. Use technology to draw the graphs is suggested but not required. Anyway, it's not required. You don't have to draw anything. I hope that I never give you any problem where you have to draw anything. But I don't mean to do that. Okay, how about this thing? What is this? F of x equals x. And the domain is x is between -4 and 4. Okay? So where's the domain again? For the first one? -4 and 4. So we only have to be concerned with going from -4 to +4. Right? And A, by the way, is equal to what here? 4. So, okay. So now this part of the statement means we only have to be concerned with going from -4 to +4. And then this tells me the shape. So what is the shape of that? It's a straight line. And is it, and what does that line look like? It's a 45-degree angle, right? 45-degree angles, halfway, halfway, right? It just says, when x is 3, y is what? 3, right? When x is 4, y is 4, right? So what's it look like? That's a 45-degree angle, right? When x is 1, y is 1. That line, right? Okay, and then it goes the same way here. But we only have to be concerned with it between 4 and -4, right? So it's not this one. It's not this one. It's not that one. So it's this one, right? So the answer is number 1. Do they have so many answers? It's not that one either. It's not that one. Okay? How about this one? So when x is equal to 2, what's y equal to according to that second formula? -2. When x is equal to 1, what's y equal to according to that second formula? -1. So what's it look like? This one, right? Okay? Any question about that? Okay, how about that? How should we do that? We can make it easier by doing it like this. Y equals the square root of 4x. We can rewrite that as what? We can take 4 outside of the square root sign and make it a... So you can write it like this, right? Right? And you can write that like this, right? But that's equal to 2, right? I'm sorry, that's equal to 2 square root of x, right? Okay? So basically, this function is like the square root of x. It's not the same as the square root of x, but it's good to start thinking about the square root of x. So if you start thinking about the square root of x, what does the square root of x look like? First of all, can the square root of x, can the domain be negative for the square root of x? Can you put in negative numbers for square roots? Like, can you say the square root of -1? No, we don't. Not in this class. Okay, we don't talk about that. So no, we can't do that. So that means you can't have anything, you can't put in a value over there and say, oh, that height is going to be there, or it's going to be here. It's not defined there. Okay, so that's first of all. Okay, what else? So, let's try plotting a few values. Well, I don't want to do the square root of 2 because I don't know what that is. So I won't waste my time doing that. But I could do this. That's easy. So what's the square root of 4? 2, right? Square root of 4 is 2. And then I don't want to do 5 or 6 or 7 or 8, but I could do 9. So what's the square root of 9? What is that? 3. Okay, and how about 1? 1. So at least we can do those, not too hard, right? And how about 0? 0. So we get that. Now, is it ever negative here? No. Square roots of positive numbers are not negative. And square roots of negative numbers we don't even talk about. So it's going to look like this. Okay? That's which one? That's the square root. That's not 2 times the square root. But okay, it's the square root. Okay? So it looks like this, so we can estimate that it looks like that. Okay? Now it turns out that it's part of a parabola, a sideways parabola. Right? It's actually basically it's a sideways parabola, but we don't have the bottom part of that parabola. But that's just a fact. Okay, now what? But that wasn't the original thing what we're trying to do. We're trying to do, so how does this change the picture? So whatever we got before we just had the square root of x, whatever we got before, we're going to do what to it? Multiply that result by 2, and that's going to be the result. And by the result, in terms of the picture, we mean what? The height. So the height is going to what? Get higher by a factor of 2. So when it was here, now it's going to be 2 times as high. So 2 times, it was 2, so now it's going to be 4, so it'll be here. It was 3, so now it's going to be 6, right? It was 1, so now it's going to be 2. It was 0, so now it's going to be 0. So it's going to look like that. Okay? And that's a way to think about that one, right? So that's this one, right? So what is the picture? Is it this picture? No, obviously not. Is it this picture? No. Is it this picture? No. Is it that picture? No. Is it that picture? Could be. Is it that picture? No. So it must be this one, right? And then you can check it a little bit further. Make sure that it's right. So say A is 4, so the answer should be 4. That was right, actually. Okay, right? That's actually what we said over here as well. When it was 4, we got 4. And you can check a few other numbers as well to make sure that it's right. Okay? He does it here also. And the same kind of thing here. Okay, so more and more work for you. Okay, how about this one? Now, that is confusing to some people. Okay, let's try and think about that. So let's write that down. F of x equals, and we have 2 things. What does it say? X and 4. What does it say? If x is, if x, well, sorry, yeah. What's that say? And x. And, okay, what do they say? Minus 3, 0. And 0, 3. Okay, so it says that, right? That's what's written on it. Okay? Now, so what does this mean? Well, let me make up a situation, maybe like the stupid one I gave you before. about number of friends. And here, okay, it's kind of another stupid example. Let's say x is, again, let's say it's the same example. So x is the amount of money that you have, and f, or y, is the number of friends that you have. Okay? So what do I mean here? What does this thing mean? So what they've done is they've broken it up into two sets of domains. This is, we use this formula when x is between here and here. And we use this formula when x is between, I'm sorry, we use this formula, which is not exactly a formula, but we use this formula when x is between here and here. But what does that mean? How do we interpret that? This means that what? If I have a between -3 and 0 dad, right? If the amount of money I have is between 0 and -3, then use this formula to know how many friends I have. Now that's going to tell me I have negative friends, so it's kind of, as I said, it's a completely silly thing to say, but I'm just trying to give you an idea. So this would mean I'll have so when x, if I have, let's say this is the amount of money I have in thousands of dollars. So if I have -$1,000, that means x is equal to 1, -1. Okay? In other words, I owe $1,000, so x is, let's say, that means x is -1. Then how many friends do I have? -1 friends. Let's say that means I have an enemy, one enemy. Okay, no, not 1,000 enemies. This is one enemy, let's say. Okay? Okay? If I'm in debt $2,000, how many friends do I have? -2 friends, so I have 2 enemies. And if I'm in debt $3,000, how many friends do I have? -3, so I have 3 enemies. Okay? So suppose this was like some weird, let's make it a game, like a video game. So maybe you could have a video game like that, right? On the other hand, if you have between 0 and $3,000 in your bank account, then you have 4 friends no matter what. Whether you have $1,000 or $2,000 or $3,000, you still have, according to this video game rules, you still have 4 friends. So that's the way this looks. Anyway, so the point is that if you had that weird set of rules in the video game, you couldn't write a single simple function to describe the number of friends you had. The number of friends you have looks like this. If you're anywhere in this range, if you have this amount of money, the number of friends you have is what? 4. So it looks like that. This is 4. And like that. Okay, on the other hand, when you have, in this video game rules, if you have -$1,000, if you owe $1,000, how many friends do you have? -1, you have what? You have -1 friends. Right? If you have this, you have -2 friends. And here, -3 friends. So the picture looks maybe like that now. Something like that. Okay? You understand? That's the rules of the game. That's not, somebody could make a video game, right, on iPhone, and this might be the rules for the game, right? They could easily design a game that had these rules, right? They could definitely do that. But you could, now, so suppose this was the rules, right? How can you make a function that tells you, so y is number of friends, and x is amount of money you have. can you give me a function y equals f of x and give me some nice little formula like x squared or x plus 2 or something? No, you can't do it. Because it's not a smooth function. And all those functions like x squared or 3x plus 1 or something, they're all smooth functions. Right? So you couldn't give me any simple formula. You have to break it up into separate domains that give a formula for each part of the domain. And that's what they did here. They broke it up into this domain. You have one formula for that domain, and another formula for a different domain. Okay, so if you want to express some situation like this, you have to do it like this. You can't just write, oh, y equals x cubed minus 6x plus 8. It's not going to work. Because that's going to be a smooth curve. But this is obviously not a smooth curve. Right? So you have to break it up into pieces. And this is called a piecewise defined function. Because it's in pieces. Right? So you have different formulas depending on where in the domain you are. So you could easily imagine that that situation might come up in some cases in the real world. So they made up this way of explaining that or expressing that. Okay? So we have this function. So what's the picture? Which one is right? So it could be this one, could be this one. What's the difference between these two? Oh, okay, there's some small differences, not much. And how about this one? No, that doesn't look right. And this one doesn't look right. So these two are not right. So what's the difference between this one and this one? Any difference? Hardly. But you can see if you look really carefully, this has an open circle and a closed circle, whereas this one is closed and open. So which one is the correct one? Someone said this one is correct. Why would they argue that this one is correct? Because of this symbol here. What do I mean by that? Is that a less than symbol or a less than or equal to symbol? You read that? Is that a less than symbol or a less than or equal to symbol? Less than or equal to. If it was a less than symbol, then this wouldn't be the right answer. Rather, this wouldn't be the right answer. But it isn't. It's a less than or equal to. Why? So what difference does that mean? So this says what? If x is equal to 0, which formula do I use? This one, top one, or bottom one? If x is equal to 0. Bottom one. So what number? So when x is equal to 0, what should the height be? 4. That's what this one is. Whereas, right, that's because this is a closed circle here, open circle. So the height is 4. How about this one? When x is equal to 0, what's the height? No. Here, this one. When x is equal to 0, what's the height? 0. What does this closed dot mean? Means that's the height. What does this open circle mean? Means that's not the height. Okay? Alright, so that's how you do that game. Any questions? Okay, let's take a 5-minute break, and then we'll have a test. No, sorry. Let's take a 5-minute break, and then, now we have something else to do in our 5-minute break. So I want to ask the two TAs, so you can stop that thing.